That is such attention to detail. And I love it. This is why you've got the physicist on your side, because this level of attention to detail is ridiculous. Hello and welcome to this episode of Astrophysicist Reacts with me, Dr Becky Smethurst. This is the show where we have some fun watching some sci-fi, but we also see what we might learn about the laws of physics along the way, either from, the things that the show creators got right, or usually for plot reasons when they decided to ignore some of the laws of physics. And we chat about how things would have been different if that wasn't the case. Now, last episode I reacted to the movie Contact, and in that episode I asked you lot to essentially put in the comments what you wanted to see me react to next. And an overwhelming majority of you said The Expanse. Now, I have to admit, I did try and get into the show a couple of years ago. I think I watched the pilot and it didn't grip me. I think I fell asleep in it, to be quite honest. And then I just kind of forgot that it existed until you all reminded me of it again. So I just rewatched that pilot, didn't fall asleep, and I'm about to watch season 1, episode 2. Now, I feel like I have to say this before we begin, because as a scientist, I'm very aware that I have a bias going into this. I guess we can't really call it an experiment, but let's call it an experiment, because so many of you and so many of my colleagues as well, like Katie Mack, for example, have all raved about how they think that The Expanse is the most accurate sci-fi show currently on TV, which is some high stakes. I'm kind of going into this with a little bit of confirmation bias, which isn't what you want. So I'm going to try and be as objective as possible while I watch and react to season 1, episode 2 of The Expanse. So you might think that a tiny piece of debris wouldn't have that big of an impact on a spacecraft, but actually the smaller the piece of the debris, the bigger danger they usually are to some extent anyway, because when they're that small and they're traveling that fast as well, it's essentially like a tiny bullet hitting your spacecraft. So instead of something that's much larger, which might maybe leave a dent, glancing blow kind of thing, the smaller pieces of debris actually punch straight through. It's a massive concern, for example, for the International Space Station. If there is any debris that's being tracked that they know has had a collision and turned into lots of smaller pieces, they tend to have evacuation procedures in process for the International Space Station, because if, a tiny piece of debris just completely goes through those metal walls and, ruins your essentially seal that's keeping your astronauts alive in there, it's not exactly a good thing, which is why debris like this can be really bad for a spacecraft.
We're not going anywhere.
That was weird. So she turned the engines off, but all the power is still on, because all those computer desks are still on, the lights are still on. But they had to turn on their magnetic boots, which I think hold them down to the metal surface, which means that their artificial gravity has now been turned off. So that's somehow tied to the engine and not to the power. So in Passengers, the ship has a power failure and they're artificial gravity fails when she's in the pool and it's terrifying. But here the artificial gravity is not tied to the power, it's tied to the engine. So I'm really intrigued now what they could have done to produce artificial gravity that would be tied to the engine, because the craft was not any sort of special shape. It was sort of a little command module-y thing, not say in The Martian, where they have that craft that's sort of a circle that spins. It's that same feeling that you get when you're on a roundabout and you spin really fast and you can feel that force pushing you back as you're spinning, right? If you can spin your craft, then you'll have the same thing, this force feeling it's pushing you outwards, and so it's sort of pushing you into the floor. And that's how they produce artificial gravity. And that would be tied to the engine, because I guess it would be the engine that's sort of powering it to move in a circle, but this isn't moving in a circle, so I'm intrigued. I'm gonna keep watching and see if I can figure it out, because I couldn't figure it out in the pilot episode when they were on this sort of big long ship. I'll keep watching. just enjoy it, Becky. Don't try and overthink it.
He's an opiate smuggler and a terrorist.
The Secretary General.
He didn't want
The
to
Secretary
talk.
General has publicly disavowed gravity torture. If you want to talk to that belter, you put him in the tank.
Gravity torture. That's kind of crazy that they've thought to actually use that in the story. Like, yes, bodies would completely grow up differently under different strengths of gravity. So, for example, like Martian gravity is like a third that of Earth's. A tiny asteroid in the asteroid belt, like Ceres, would probably be something like, I don't know off the top of my head, like a hundredth or so of Earth's gravity, if that. So your bones would have developed differently if you'd only ever experienced that gravity. They wouldn't be as strong to resist that sort of like pull downwards all the time. People would probably be taller. If you brought them to Earth, they would probably barely be able to stand up. You know, even astronauts that come down from the International Space Station where, okay, it's zero gravity, after like 6 months, they come back and say Earth gravity is crazy to them. It's like it's sort of like crushing them to the ground is what it feels like after having been weightless for so long. And also, like, it'd be really difficult to breathe as well if you weren't used to that strength of gravity, because you just have this air pressure, this column of air pressure just crushing down on you that would make it so difficult. So, I mean, okay, fair enough, our astronauts don't necessarily notice those kind of differences. They've probably not grown up, you know, for years and years in only that sort of lower gravity. But we do notice differences to their bodies when they return to Earth after an extended time in space. So, for example, the astronaut Scott Kelly spent a year in space, whereas his twin, Mark, didn't. When he came back to Earth, we could literally have like a control in terms of a scientific experiment to actually compare to. So he actually got taller in space because, you know, like your spine isn't crushed down, or the vertebrae aren't crushed down. They sort of have space to stretch out. And there was loads of differences just from spending a year in space in low gravity, or in zero gravity as on the International Space Station. So the fact that they've actually thought that through and thought to include it is really cool. Like, that's nothing to do with technology or, you know, like aliens or anything like that you normally see in sci-fi. It's literally just pure physics.
You know who I am?
I've heard of you, yes.
So they've put the belter, this person that's grown up on the asteroid belt with this weak gravity, into a tank of water instead of just leaving them out in the air, essentially, where they would be fully subject to Earth's gravity. In the water instead, they've got the water to help take some of their weight, right? You're more buoyant in water. You'll notice when you get in a pool, right? Or in the sea, you do feel naturally lighter. And you can really tell that if it's a very, very salty ocean, like something like the Dead Sea or something like that, a salty body of water, you obviously are very, very buoyant. You know, you can float without any effort. So this will obviously take away some of those crushing effects of the Earth's gravity for him, and he'll feel a lot lighter. To me, that's what they're talking about in that song that's like, I feel like an astronaut in the ocean. Anytime I get in the sea and you feel that much lighter, you do feel like you could be sort of like in zero gravity, like in space, or at least that's kind of what I think that lyric means anyway.
Now carry on.
Oh, piece of shit!
Kick it!
We have connection.
No way. You kind of just kicked it and it worked. Oh my god. It's like, have you tried turning it off and turning it back on again? God. People are dying here. I love how the door for the airlock is like an old window crank on a car.
Someone heard us.
Someone heard us?
Yeah.
Are they coming?
Just waiting for the bounce back.
I like that they've included that there is actual light travel time. So any message you send, you know, you're going to have to wait for that to get there, and then for the light to travel back to you to actually receive a reply as well. And in the solar system, you know, that's not going to be years or anything like that, like with sort of like interstellar light signals, but it will be, you know, minutes to hours. For example, like Earth to Mars travel time, depending on where Earth and Mars are, if they're like their closest approach, it's 5 minutes or so, or if they're at their furthest possible distance apart in their orbits, it's more like about half an hour-ish or so. So that gives you some idea in terms of, you know, light travel distance in the solar system. So I guess they're hoping it's someone close by that's heard this message so that they can actually come and rescue them. So they should only be a couple of light minutes away, hopefully, and so they shouldn't have to wait too long for this message to come back.
Ship en route. How far? It's almost 80,000 clicks.
They keep using clicks as a distance measure, and I have not heard of clicks. The term click is derived from the word kilometre. Oh, okay. So 1 click equals 1 kilometre. So they're 80,000 kilometers away. That is quite the distance. So just for context, like the Earth and the Moon are like about 300,000 kilometers away on average or so, I think. Editing Becky will tell me if I'm right, if I've remembered that number right. What just happened to that? Like he poured that water and it didn't pour straight out of it. So yeah, okay, so that must mean that they're spinning to get the artificial gravity on this station. So I think they're the Ceres station, so they must be spinning, in which case the point where you start spinning the water, you know, it's not going to fall straight down, it's going to fall with the spin. And so you're going to have to like relearn where to pour from, in the same way that like you learn, say, for example, when you're playing tennis or something like that, you learn where to put your racket because you know where roughly the ball is going to be once it's bounced. You're almost going to have to like relearn where to pour your water from to account for the fact that it won't fall straight down, because your force of gravity is not coming from straight down. It's coming from the fact that this whole thing is spinning. That is such attention to detail. And I love it. This is why you've got the physicists on your side, because this level of attention to detail is ridiculous. So that massive ship that just took them aboard, like that didn't appear to be spinning at all, and yet there's still artificial gravity aboard it. So like, I'm still confused. Like, if it's not spinning, like, clearly some of them are spinning to get their artificial gravity, like the Ceres station, but then, and some of the smaller craft, but these larger craft aren't. Oh, that's bugging me that I can't figure it out.
You are prisoners of the Mars Congressional Republic. Move and you die.
Uh-oh. Yeah, I mean, I really enjoyed that. Like, I can see why people like it so much, just because there's so much attention to physics detail, which obviously as a nerd I appreciate. It's amazing to think about how they've built this story around resources, essentially, like gravity almost is a resource, but then like water and air, things you take for granted on Earth, you know, not necessarily being readily available. And it actually reminded me of something that happened last week, which was the Perseverance mission, which is currently on Mars, made oxygen out of the carbon dioxide that makes up the majority of the Martian atmosphere. They made about like 5 grams of oxygen, which is enough to keep a person alive for about 10 minutes or something. But somewhere like Mars, you know, with that, you know, natural resource, if you want to call it, the carbon dioxide, would be able to sustain themselves to make their own oxygen on Mars, as long as you put it, you know, inside some sort of tent, or I think they were kind of like little domes, like the Eden Project in Cornwall, I guess is how I saw them in the pilot. If you could fill those, then, you know, you would have your own way of producing oxygen from the natural resources. And that is kind of like the first step to humans actually putting a base that we could live on Mars. And so that's why everyone got excited last week when Perseverance actually did this, because it was that first step. But you can imagine, like, out in the asteroid belt and beyond, like, those natural resources aren't necessarily there for you. They were even mining ice from around the rings of Saturn to melt into water for drinking out on Ceres. So it's amazing, you know, how many wars have been started over fighting basically over resources. So it's amazing to think how they've sort of taken that, what is almost like a trope of humanity really, and just completely transplanted it into this sort of futuristic society that's conquered the solar system. And this is why it reminds me of Red Rising by Pierce Brown as well, because they play on that as well in that book. And yeah, it's just so well done. The gravity thing though is still bugging me, so I'm actually gonna look this up. Like, how do they actually have artificial gravity in the Expanse? Like, what do they do? Who knew there was like a whole page on Wikipedia about artificial gravity in fictions? Where's the Expanse? Oh, there it is. Okay, in the Expanse series, space stations generate artificial gravity by rotating, as do spun up, hollowed out asteroids, usually around 0.3 G, so Martian gravity-ish. Moving ships under constant thrust also simulate gravity by linear acceleration. Right, okay, that's how they do it. So those big, long ships we saw, by constantly accelerating, they are producing a force that would create gravity. So you would have to have all the floors that you're walking on your ship sort of perpendicular to whatever direction that you're accelerating it in. So I guess it would be kind of like a building on its side that's thrusting through space, essentially. I guess you can kind of recreate that feeling like if you're in a lift or elevator, as Americans call them, right? When you feel it starting to push you up, you feel that force of acceleration as the lift goes, and you feel that sort of extra force. And when it decelerates, you sort of get that swooping in your stomach, right? As you feel lighter all of a sudden. That's the kind of force that they're generating there, because when we talk about gravity, like historically it was described as a force, but technically gravity is not a force. Like Einstein described gravity as massive objects curving space-time, and then we, as other objects traveling on that curved space-time, essentially feel an acceleration because of it. So gravity isn't really force, it's more of an acceleration. So if you can generate an acceleration, then essentially you can generate artificial gravity as well. And I love that that's what the show has chosen to do. And I feel like only people who are really in the know with physics would necessarily get at that from the show, and would just assume that it did the usual sci-fi thing of being like, we somehow managed to figure out how to generate our own gravity in space. Don't worry about it. They've actually worried about it. And that's what makes me really appreciative of this show, is that they went to those lengths to do it. All right, that was me reacting to season 1, episode 2 of The Expanse. If there's other episodes of this series that you want me to watch, or if there's other movies or TV films that are sci-fi based that you want me to react to, let me know down in the comments. Just going to pick up on a couple of things I noticed in the comments from last episode. First of all, The Martian. Yes, 100% have seen that film. One of my favorite films of all time, and I probably couldn't react to it because instead I would just be quoting it at you word for word. I've seen it that many times. Interstellar and Arrival were requested a lot. I have to be honest, didn't enjoy those films that much. It was specifically the ending of both of them that I didn't enjoy. I just couldn't turn my astrophysicist brain off when I was watching Interstellar specifically. So I've seen them both once. I could technically do a reaction to them, but I'd be going into it knowing that I don't like them. So if there's any other films or TV series that you think of that you want me to react to, let me know. Maybe something I haven't seen before as well would be really, really cool. But until next time, enjoy some good sci-fi, and if you get a chance, head outside and look up at those stars, because they are, as always, truly spectacular. Before we get to everybody's favourite part, the bloopers, I just want to say a big thank you to this week's video sponsor, Brilliant. Brilliant is a website and an app that gets you to learn by doing, which personally is the way that I learn best. And they have a huge range of courses across science, maths, and computer science that are interactive, which I think makes them way more fun and engaging. Plus, you can learn at your own pace without worrying about tests or exams. And if there's anything you don't understand, there's always a much longer explanation to help you out. For example, if you want to start to learn more about gravity after watching The Expanse, Brilliant has a whole course to introduce you to the fundamentals underpinning our understanding of gravity, from Newton's laws all the way to Einstein, including a whole section on gravity as an acceleration, not a force. Plus, they even work in some Python coding to some of their courses, which I always say is the one thing that aspiring scientists should learn to do. So if that sounds like something you would be up for and you want to support me and my channel, head to brilliant.org/Dr Becky. That's DRBECKY, and sign up completely for free. Plus, the first 200 people that go to that link will get 20% off an annual premium subscription. So thank you so much to Brilliant. And now, roll those bloopers. The main guy in this kind of looks like the Darkling from Shadow and Bone, but that might just because I've just finished Shadow and Bone. I wish I hadn't. I'm now like bereft because it's over. See there, he kind of looks like Bucky. But again, it could be just because I'm like bereft that Falcon and the Winter Soldier's over as well. Oh God. Just dribbled water all over myself. Like, astrophysicist. Like, that's just your daily reminder that intelligent people are just not that smart. I feel like an astronaut in the ocean, yeah. Oh, sorry. I just got so distracted by the artificial gravity in fiction Wikipedia page. It was so interesting. I was like, oh yeah, look at all these ways that it's been employed in various different films and books. Anyway, outro. I need to do an outro. God. I actually think that was like nearly 5 minutes of me reading that Wikipedia